The engineer knelt in the mud, examining the damaged anti-tank gun. The barrel was bent from a near miss. The carriage was cracked. The crew was dead. Around him, the defensive line was collapsing. German tanks were advancing, their tracks grinding across the frozen earth. Infantry units were falling back. Officers shouted orders that no one could execute. The defensive positions had been prepared according to doctrine, but doctrine assumed equipment that worked and crews that survived long enough to use it. Neither assumption held. The engineer had been sent forward to assess why the anti-tank defenses were failing so completely. The answer was obvious. The guns were too few, too exposed, and too vulnerable. When a Panzer identified an anti-tank position, it destroyed it before the gun crew could achieve a killing shot. The armor was too thick for the weapons available to penetrate its safe range. The crews had to wait until the tanks closed to distances where return fire was lethal. Most crews did not survive their first engagement. The engineer knew that more guns were not coming. Production could not meet demand. The factories were producing as many as possible, but the front consumed them faster than they could be replaced. Replacements took weeks to arrive, and by then the line had moved or collapsed entirely. He needed a solution that did not require equipment that did not exist. He sat in the ruined position and thought. Then he laughed. The sound was inappropriate given the circumstances, but he could not help it. The idea was absurd. It violated every principle of anti-tank defense. It would be dismissed as a joke, but it might work. To understand how a joke became the most replicated field modification on the Eastern Front, we must go back. By the winter of 1941, the German invasion of the Soviet Union had driven deep into Soviet territory, but had failed to achieve the decisive victory Germany anticipated. The Wehrmacht had expected the Soviet Union to collapse within months. Instead, resistance stiffened as German supply lines stretched, and Soviet forces withdrew, regrouped, and counterattacked. The war settled into brutal attrition. German forces held most of the territory they had captured, but they could not advance further without rest and resupply. Soviet forces lacked the strength to push the Germans back decisively, but could contest their positions and inflict casualties. Both sides prepared for renewed offensives in the spring. The winter brought harsh conditions that affected both armies, but the Soviets adapted more effectively. German logistics had not anticipated operating in temperatures that froze lubricants, cracked engine blocks, and made weapons unreliable. Soviet equipment was designed for these conditions. Soviet troops were accustomed to them. The Germans suffered disproportionately, but German armor remained a critical advantage. Panzer divisions, even weakened and operating in winter conditions, could break through defensive lines that lacked adequate anti-tank capabilities. Soviet infantry feared tanks. Anti-tank guns existed, but they were scarce and their effectiveness was limited. Early Soviet designs had inadequate penetration against German frontal armor. Later designs had better performance, but were not available in sufficient numbers. Infantry units often faced armor with only grenades, Molotov cocktails, and desperation. The challenge of defending against armor was not simply a matter of firepower. It was a matter of geometry and timing. Anti-tank guns had to be positioned where they could engage approaching tanks at effective range. They had to be concealed to avoid detection and destruction by return fire. They had to have clear fields of fire that allowed them to engage multiple targets. Crews had to be trained to operate under stress, to calculate range and lead, to fire and reposition before counter-battery fire arrived. All of these requirements were difficult to meet in static defensive positions. They were nearly impossible to meet in hasty defenses established during withdrawals or in counterattack operations. Soviet doctrine emphasized mobility and mass. Large numbers of troops advancing on broad fronts, overwhelming enemy positions through weight of numbers. This worked against infantry. It did not work against armor. Tanks could maneuver, concentrate fire, and break through weak points faster than infantry could react. Anti-tank defenses required concentration at likely approach routes, but those routes were often obvious to attackers. German doctrine emphasized exploiting gaps and avoiding strength. Panzer commanders probed defenses, identified weak points, and attacked there. Soviet defenders had to either defend everywhere, spreading resources too thin, or defend key points and accept that other areas would be vulnerable. The engineer who would solve this problem in an unexpected way was Captain Mikhail Kuzmin, and he had been assigned to a rifle division defending a sector west of Moscow. Kuzmin was not a combat officer. His training was in civil engineering. Before the war, he had designed bridges and roads. He understood materials, stress loads, and how structures failed. He had been conscripted in 1941 and assigned to the engineering branch based on his background. He had spent the first months of the war constructing fortifications, repairing roads, and demolishing bridges to delay German advances. He was competent and methodical, but he had no experience with weapons or tactics. His superiors recognized this and used him in roles that required technical knowledge rather than combat leadership. In December 1941, his division was defending a position that controlled access to a river crossing. The position was important enough that German forces would likely attack it, but not important enough to warrant significant reinforcement. The division had 3 anti-tank guns to defend a front of approximately 8 kilometers. This was inadequate. Doctrine called for at least 1 gun per kilometer of front, preferably more in critical sectors. The division commander knew this, but had no solution. He could request additional guns, but requests went unfulfilled. Production priorities favored other fronts. The division would have to defend with what it had. Kuzmin was ordered to conduct a survey of the defensive positions and recommend improvements. He spent 2 days walking the line, examining fields of fire, assessing obstacles, and talking to infantry commanders. The problems were clear. The anti-tank guns were positioned to cover the most likely approach routes, but those routes were obvious. German reconnaissance would identify the gun positions quickly. Once identified, the positions would be suppressed by artillery or engaged by tanks at standoff range. The guns could be relocated, but moving them required time and effort. Gun crews were exhausted. Moving positions after each engagement was not practical. The alternative was to create dummy positions to draw fire, but this required resources and effort that were not available. Kuzmin also observed that the infantry had constructed field fortifications using standard techniques. Trenches, firing positions, and communication trenches followed the patterns taught in training. The fortifications provided cover against small arms fire, but were not effective against armor. Tanks could drive over trenches, collapse firing positions, and isolate units. Infantry units that stood their ground against armor suffered catastrophic casualties. Units that withdrew early gave up positions without contest. Neither option was acceptable. Kuzmin considered what resources were available. The division had limited ammunition, few anti-tank weapons, and no prospect of reinforcement. But it had manpower. Soldiers could dig. They could move earth, construct obstacles, and place mines if mines were available. Mines were effective against armor, but the division had almost none. Mine production had been disrupted by the loss of industrial areas. Existing stocks had been expended. Improvised mines could be constructed from artillery shells, but fuses were scarce and the results were unreliable. Kuzmin thought about the problem from a different angle. The goal was not to destroy every tank. The goal was to prevent tanks from reaching and overrunning the defensive positions. Destruction was one method. Immobilization was another. If a tank could not move, it could not advance. If it could not advance, it was no longer a threat to the infantry line, even if it remained capable of firing. The question was how to immobilize tanks without anti-tank weapons. Obstacles could do this if they were strong enough and properly positioned. Standard anti-tank obstacles included ditches, dragon's teeth, and abatis. All required significant construction effort and materials. The division lacked both. Kuzmin thought about how tanks moved. They used tracks. Tracks distributed weight across a large surface area, allowing tanks to cross soft ground that would bog down wheeled vehicles. But tracks were also vulnerable. If the track was damaged or thrown, the tank was immobilized. German crews could repair thrown tracks, but it took time. While they were repairing, the tank was vulnerable. Infantry could approach and destroy it with grenades or Molotov cocktails. Artillery could target it. Even if the tank could not be destroyed, immobilizing it removed it from the attack. Kuzmin considered how to damage tracks. Mines worked, but were unavailable. Obstacles could work if they were designed to catch and break tracks rather than simply block movement. He thought about the materials available. Wood from destroyed buildings, metal from wrecked vehicles, rails from damaged rail lines. None of these were standard anti-tank construction materials, but they were available in quantity. He began sketching designs. The idea he developed was simple to the point of being ridiculous. He proposed constructing obstacles from wooden logs sharpened to points and embedded in the ground at angles supplemented by sections of rail and scrap metal positioned to catch tank tracks. The obstacles would not stop a tank. A Panzer could drive over wooden stakes, but if the obstacles were positioned correctly, they would force the tank to climb at an angle that exposed its underside or caught its tracks on the protruding metal. The key was not the strength of the obstacle, but its geometry. A tank climbing over an angled stake would lift its front, exposing thinner belly armor. A tank turning to avoid one obstacle might catch its track on another. The obstacles did not need to be individually strong. They needed to be numerous and positioned to create dilemmas. Kuzmin calculated that obstacles spaced irregularly across the approach routes would force tanks to maneuver constantly. Maneuvering reduced speed. Reduced speed gave anti-tank guns more time to engage. Even if the guns missed, the slowed tanks would be vulnerable to infantry attacks. The obstacles themselves might immobilize some tanks by catching tracks or breaking suspension components. The design required minimal materials and could be constructed quickly by infantry with basic tools. Kuzmin presented the idea to his division commander. The commander listened, then asked if Kuzmin was joking. Wooden stakes against Panzers. It sounded absurd. Kuzmin said he was serious. The stakes would not stop the tanks directly, but they would disrupt them. Disruption was enough if it bought time for other weapons to engage. The commander was skeptical, but had no better options. He authorized a small-scale test. Kuzmin was given one rifle company and 2 days to construct a section of obstacles covering one likely approach route. If the Germans attacked through that sector, the effectiveness could be assessed. If not, minimal resources would have been wasted. Kuzmin organized the work. Soldiers cut logs from nearby forests, sharpened them using axes and saws, and dug holes to emplace them. The stakes were positioned at angles pointing towards the expected direction of attack. Metal fragments from destroyed vehicles were welded or wired to some stakes, creating barbs. Sections of rail were embedded vertically in clusters, creating thicket of metal that would catch tracks. The work was hard but straightforward. The soldiers understood what they were building, even if they doubted it would work. Some made jokes. They were building a garden for German tanks. They were constructing a monument to futility. Kuzmin ignored the comments and focused on positioning. The obstacles had to be placed where tanks would encounter them during maneuvers, not where they could be easily seen and avoided. He studied the terrain and identified low areas, defile and paths that offered concealment or better footing. Those were the areas tanks would naturally prefer. He concentrated obstacles there. On December 15th, German forces launched a probing attack in the sector. A company of infantry supported by 5 Panzer III tanks advanced toward the Soviet positions. The tanks moved forward in a line, infantry following. Soviet artillery engaged, but the barrage was light and the tanks continued. The lead tank reached the obstacle field. The crew did not identify the obstacles until they were almost on top of them. The stakes were low and partially concealed by snow. The tank drove forward, climbing over the first stake. The stake snapped, but the tank's nose lifted. The driver corrected, lowering the front. The tank moved forward again and encountered a cluster of embedded rail sections. The driver attempted to turn, but the right track caught on the metal. The track tension increased. The tank lurched and stopped. The driver tried to reverse, but the track was jammed. The crew realized they were immobilized. They attempted to clear the obstacle, but Soviet infantry began firing. The crew buttoned up and used the radio to call for support. The other 4 tanks maneuvered to assist, but encountered similar obstacles. One tank threw a track, attempting to climb over a stake with welded metal barbs. Another became stuck attempting to push through a cluster of rails. The remaining 2 tanks slowed, cautious of the obstacles. This gave Soviet anti-tank guns time to engage. One gun scored a hit on a stationary tank, penetrating the side armor. The tank caught fire. The crew bailed out. The attack stalled. German infantry could not advance without armor support. After 30 minutes of ineffective maneuvering, the Germans withdrew, leaving 2 immobilized tanks behind. Soviet infantry moved forward and destroyed both tanks with grenades. The result was reported immediately. The division commander was surprised. The obstacles had worked not by stopping the tanks, but by slowing and immobilizing them long enough for other weapons to be effective. Kuzmin's approach had turned a desperate situation into a viable defense. The commander ordered the obstacles to be extended across the entire division front. Over the next week, infantry units constructed thousands of stakes and embedded metal obstacles. The work was labor-intensive, but required only hand tools and materials scavenged from the battlefield. The defensive line became studded with obstacles that looked crude but functioned effectively. German attacks in subsequent weeks encountered the obstacles repeatedly. Tank commanders learned to recognize them and attempted to avoid them, but avoidance required maneuvering into areas that were covered by anti-tank guns or were otherwise less favorable. The obstacles created a tactical problem with no clean solution. Drive through them and risk immobilization. Avoid them and accept worse positioning. Either choice degraded the effectiveness of the armor. Soviet defenders gained confidence. The obstacles were not perfect. Some tanks got through. Some obstacles were destroyed by artillery. But overall, the defensive line held better than it had before. Casualties decreased. German progress slowed. Word of the obstacles spread. Other divisions heard about the technique and requested information. Kuzmin was ordered to brief neighboring units on construction methods. He traveled to several divisions, explaining the principles and demonstrating construction techniques. The method was adopted widely. By early 1942, obstacles of this type, which Soviet soldiers began calling hedgehogs due to their spiked appearance, were appearing across defensive positions throughout the front. The design evolved. Some units added barbed wire to complicate infantry approaches. Others incorporated actual mines when they became available. Some experimented with different angles and spacings to optimize effectiveness against different tank types. The basic principle remained the same. Use cheap available materials to create obstacles that disrupted armor movement and created opportunities for other weapons to engage. The cumulative effect was significant. German armor, which had previously been able to move relatively freely across much of the front, now faced obstacles that required either engineering support to clear or careful maneuvering to avoid. Both options consumed time and reduced operational tempo. German infantry, which depended on armor support, found themselves exposed more often. Attack success rates declined. The German response was to adapt their tactics. Engineers were brought forward to clear obstacles before tanks advanced. Infantry was used to probe defenses and identify obstacle locations. Artillery was concentrated on known obstacle fields to destroy them before attacks. All of these responses were effective to varying degrees, but they required resources and coordination. Attacks became more complex and slower to execute. The operational advantage that German armor had provided was eroding. Not because Soviet anti-tank weapons had improved dramatically, though they had, but because the operational environment had become more difficult. Tanks could still break through when concentrated and supported properly, but the cost in time and resources had increased. Strategic planners in the German High Command noted the change. Reports from the front indicated that Soviet defensive capabilities had improved. Analysis attributed this partly to better tactics and partly to the proliferation of field obstacles that disrupted armor operations. The obstacles themselves were not considered significant individually, but their cumulative impact was undeniable. Recommendations were made to develop countermeasures. Additional engineering assets were allocated to frontline units. Mine flails and other obstacle clearing equipment were prioritized for production and deployment. But these measures took time to implement, and the Soviets continued to refine their obstacles. Kuzmin was promoted to major and reassigned to a staff position where he worked on standardizing obstacle construction across multiple armies. He wrote technical manuals describing optimal designs, construction methods, and placement strategies. These manuals were distributed to engineering units throughout the Red Army. The obstacles became formalized as part of Soviet defensive doctrine. They were no longer improvised field modifications. They were standard procedure. Kuzmin's contribution was recognized officially. He received commendations and medals, but he remained uncomfortable with the attention. He viewed the obstacles as a practical solution to a specific problem, not as a brilliant innovation. The fact that the solution had been necessary reflected the desperate circumstances the Red Army faced in 1941 and 42. Better equipment and better training would have been preferable, but those were not available, so improvisation was required. After the war, Kuzmin returned to civil engineering. He worked on reconstruction projects, rebuilding infrastructure destroyed during the war. He designed bridges, roads, and buildings. He rarely spoke about his wartime service. When colleagues learned of his role in developing the Hedgehog obstacles, they asked questions. Kuzmin answered briefly. The obstacles had been a response to necessity. They worked because they exploited the physics of tank movement and the limitations of German tactics. There was no mystery to it, just observation, reasoning, and implementation. The obstacles remained in use throughout the war. Their design continued to evolve. By 1943, Soviet defenses incorporated multiple layers of obstacles integrated with minefields, anti-tank ditches, and gun positions. The Hedgehog stakes were one element in a comprehensive system, but they remained important because they were cheap, quick to construct, and effective. Even as Soviet industrial production recovered and more anti-tank guns became available, the obstacles were retained. They multiplied the effectiveness of the guns by channeling armor into killing zones and slowing it enough to allow accurate fire. Post-war analysis by military historians examined the impact of the obstacles on German operations. The consensus was that while no single factor determined the outcome on the Eastern Front, the cumulative effect of improved Soviet defensive tactics, including the widespread use of improvised obstacles, contributed significantly to blunting German offensives. The obstacles did not stop the Wehrmacht, but they slowed it down and imposed costs that Germany could not sustain indefinitely. Each delay gave the Soviets time to regroup, reinforce, and prepare counterattacks. Each immobilized tank was a tank that could not be used elsewhere. The attrition added up. The human cost of the fighting on the Eastern Front was staggering. Millions died on both sides. The obstacles Kuzmin designed contributed to that toll. German tank crews immobilized by obstacles were often killed by Soviet infantry or artillery. Soviet soldiers constructing and defending the obstacles died in German attacks. The obstacles did not reduce casualties. They redistributed them. German losses increased. Soviet losses in some sectors decreased. The net effect was a shift in the balance, but individual tragedies multiplied regardless. Kuzmin understood this. He had designed the obstacles to save Soviet lives by killing or immobilizing German soldiers. This was the logic of war. It did not make him comfortable. After the war, he avoided discussing the specifics of engagements where his obstacles had been used. He provided technical information when asked, but he did not dwell on the human consequences. He had done what was necessary. That was sufficient. The obstacles were not the only innovation born of desperation on the Eastern Front. Soviet forces developed numerous improvised solutions to equipment shortages and tactical challenges. Anti-tank dogs trained to run under tanks with explosives strapped to them were tried with mixed results. Molotov cocktails became standard infantry anti-tank weapons. Snipers were trained and deployed in large numbers to disrupt German operations. Partisans behind German lines sabotaged supply routes and tied down troops. Each innovation addressed a specific problem. Some worked better than others. The Hedgehog obstacles were among the most successful because they were simple, scalable, and did not require specialized training or equipment. Any infantry unit could construct them. Any defensive position could incorporate them. The obstacles democratized anti-tank defense. Units that lacked anti-tank guns could still delay or stop armor using obstacles and improvised weapons. This changed the tactical calculus. German commanders could no longer assume that Soviet infantry without heavy weapons were helpless against armor. Even poorly equipped units could create problems. The psychological impact of the obstacles was also significant. German tank crews who had experienced relative freedom of movement early in the campaign became more cautious. They knew that obstacles could immobilize their vehicles and leave them vulnerable. This caution reduced the aggressiveness of German armor tactics. Units that might have pushed forward quickly now advanced methodically, probing for obstacles and waiting for engineering support. The slower pace gave Soviet defenders more time to react and adjust. It also gave Soviet commanders more time to position reserves and organize counterattacks. The cumulative effect was to reduce the operational tempo of German offensives. Speed had been one of Germany's key advantages. The Blitzkrieg doctrine depended on rapid movement and exploitation of breakthroughs. Obstacles that slowed movement degraded the doctrine's effectiveness. The Eastern Front became a grinding war of attrition. The type of war Germany was least equipped to win. Soviet industrial recovery in 1942 and 1943 allowed increased production of tanks, artillery, and other heavy equipment. The Red Army that counterattacked at Stalingrad and later at Kursk was far better equipped than the army that had defended Moscow in 1941. But the obstacles remained relevant. Even well-equipped armies benefited from defensive measures that were cheap and effective. Soviet doctrine incorporated obstacles into offensive operations as well. Advancing units constructed obstacles behind them to protect against counterattacks. Engineers prepared obstacle belts that could be quickly placed if an advance stalled. The flexibility of the Hedgehog design made it useful in multiple contexts. It was not just a defensive tool. It was a general-purpose method for controlling movement and shaping the battlefield. This versatility ensured its continued use even as the strategic situation evolved. German military planners studied the obstacles and attempted to replicate the concept in their own defenses. By 1943, as Germany shifted to the defensive on the Eastern Front, German engineers constructed similar obstacles using available materials. The designs were not identical to the Soviet version, but the principles were the same. Use cheap materials to create barriers that disrupted enemy armor. The Germans had the industrial capacity to produce more sophisticated obstacles, but industrial capacity was increasingly strained. Producing concrete dragon's teeth or steel hedgehogs required resources that were needed elsewhere. Field-expedient obstacles using wood and scrap metal were more practical. The fact that both sides adopted similar approaches reflected the universal logic of the problem. Armor was powerful, but not invincible. Obstacles that exploited the mechanical limitations of tanks could degrade their effectiveness without requiring expensive weapons. This logic applied regardless of which side was attacking or defending. The post-war period saw a continued interest in anti-tank obstacles. NATO and Warsaw Pact forces both incorporated obstacles into their defensive planning during the Cold War. The designs evolved to account for more powerful tanks and different terrain, but the basic concept persisted. Modern obstacles include concrete barriers, steel beams embedded in the ground, and sophisticated mine systems. But the principle that Kuzmin demonstrated in 1941 remains valid. Obstacles do not need to stop tanks directly. They need to slow, channel, or immobilize them long enough for other weapons to engage. Modern anti-tank guided missiles are far more effective than the guns available in World War II, but they still benefit from obstacles that limit target maneuverability. The integration of obstacles and weapons remains central to anti-tank defense. Kuzmin lived until 1979. He was 71. He had continued working in civil engineering until his retirement in 1971. He designed numerous structures, some of which remain in use. His reputation in the engineering community was solid. He was known as competent, methodical, and reliable. His wartime service was known to his colleagues, but it was not the primary basis of his professional identity. He was an engineer who had served during the war like many of his generation. After retirement, he lived quietly in Moscow. He walked daily, read extensively, and maintained correspondence with a few former colleagues. He avoided veterans' gatherings and did not seek recognition for his wartime contributions. When the Soviet government organized events commemorating wartime achievements, Kuzmin declined invitations to attend. He preferred anonymity. He died of natural causes in his apartment. His funeral was attended by family and a small number of friends. His obituary mentioned his wartime service in general terms, but focused primarily on his post-war engineering work. His papers, including his wartime technical manuals, were donated to a military archive. Researchers have used them to document the development of Soviet defensive tactics during the war. The obstacles themselves are difficult to quantify in terms of their impact. There is no precise count of how many German tanks were immobilized or destroyed as a direct result of the obstacles. Battlefield reports often attributed immobilizations to obstacles or mines without specifying the exact type. Post-war analysis attempted to estimate the impact by examining casualty reports, unit after-action reviews, and German intelligence assessments. The estimates vary, but most suggest that the obstacles contributed to hundreds of tank immobilizations and significantly increased the time required for German armored units to break through Soviet defensive positions. Time in warfare translates directly into casualties and outcomes. Every hour a German offensive was delayed gave Soviet forces more time to reinforce, reposition, and prepare counterattacks. The cumulative delays imposed by obstacles across multiple engagements added up to weeks or months of operational time. Those weeks and months mattered strategically. The story of the obstacles is also a story about the nature of innovation under pressure. Guzman was not a weapons designer or a combat tactician. He was a civil engineer who understood materials and structures. He applied that understanding to a military problem and developed a solution that worked because it was grounded in practical reality rather than theoretical doctrine. The solution was not elegant. It was crude, improvised, and born of desperation, but it was effective. This pattern repeated throughout the war. Effective solutions often came from individuals who approached problems from non-standard perspectives. Guzman saw tanks as engineering problems, structures that moved and could be disrupted by interfering with their movement. A tactician might have focused on destroying the tanks. An engineer focused on stopping them. The difference in perspective led to a different solution. Organizations that could incorporate diverse perspectives and unconventional ideas were more adaptable and more likely to find solutions to novel problems. The Red Army, despite its rigid command structure and political constraints, demonstrated capacity for adaptation. Effective ideas, regardless of their source, were often adopted and scaled if they worked. This pragmatism was a strength. The obstacles Guzman designed did not win the war. No single innovation or tactic did. The war on the Eastern Front was decided by the interaction of countless factors: industrial production, logistics, leadership, morale, weather, terrain, and the decisions of millions of individuals. The obstacles were one small factor among many, but they mattered. They changed the tactical environment in ways that favored Soviet defenders. They imposed costs on German attackers. They demonstrated that innovation did not require advanced technology or large budgets. It required clear thinking, practical knowledge, and willingness to try ideas that seemed absurd. Guzman's initial reaction to his own idea was laughter. He thought it was ridiculous, but he tested it anyway. The test worked. The idea spread. The impact accumulated. That progression from ridiculous idea to standard doctrine captures something essential about problem solving in extreme conditions. Solutions do not have to be sophisticated. They have to work. Guzman's obstacles worked. That was enough.